Hello everyone, today I will show you how to use QTL Design Sandbox to simulate data, fit models, and test power and FDR for market discovery. The app has four tabs at the top: README, Data, Model, Power, and Output. I will go through them in order. The first is the README tab. This is a page explaining the purpose of the app and the required R package. Before we start, please confirm that you have installed all the package we need in this Shiny app. It's also show the session info so that your analysis is reproducible. We will go to the next step to start working with data. This tab was used for prepare genotype data X and the phenotype Y for modeling. First, we need to choose active data source. You can choose generated by SetSeed, or you can choose to upload your CSV. We can first press the generate X button here. It will generate some X, and you can change the minor alley frequency or change the seed for X like 2000. Yeah. And then you can choose the number of casual markers. You can change the number by the button here and decide what effect size per casual marker you want and set the standard arrow, which is the sigma, and set the seed for Y. Also, if you want to control the PVE, you can choose here like fix sigma and scale beta, or fix beta and solve sigma. The target PVE is the variance explained, used when a control mode is selected, and then after you choose that, then you press the button Generate Y. Here we go, we have got all the data, and here is a Y histogram. At the bottom, it shows us how many rows we have, how many markers we have. If you want, you can upload your CSV file, but please ensure that your CSV file there is no missing data and the form will be Y x1 to xm, no any missing value. Let's choose some data. If you submit a valid data like large, has been loaded and the data in the preview X and the preview Y has been changed. From here, we can also see that, okay, the rows change from 200 to 300. Yeah, and the histogram of Y is also changed. Um, and what will happen if you load with data which is invalid, such as there are some missing values in the CSV file? Let's check. If we add some missing values data, like the invalid has non-A CSV, okay, we will see that the main panel is on or be cleared and there is a tips. So you need to choose another data. Okay, let's try by the generate data from set seed. And then we continue our testing. Then we move to the model page. There, the first choice is to choose the model type you want. You can choose the single marker model or multiple marker model. And then you can choose the selection threshold, which we have the statistic. You can choose from p-value, LOD score, and LRT statistics. And you can also change the threshold values you want. Okay, let's start it. This is the result of the single marker models with the statistic p-value. Here, we also provide the statistics results for the LRT statistic and the LOD score, and here it will be a column named the selected, which will indicate that, okay, this markers might be true or this marker might be false. And here, this is a sentence. I told you that how many markers in the single marker models will be selected. Okay, it is 6 over 50. If you want to change the statistics, like come to LOD score, yeah, the data will also change. Like here, the selected marker is 6 over 50, and also the visualization figure will change. And we can mention that this threshold value changed from the 0.5 to 0.83 because we have to do some calculation between them to ensure that they are equivalent when you're using the p-value, LRT statistics, and LOD score, and the calculation formula is listed at the bottom. And what will happen if we change to the multiple marker model? Okay, then we click the button fit the model. Is the result. We can see that there are 8 over 50 models, which is significant. And if we choose to the p-value, there are 5 over 50. And to the LRT statistics, it will be the 8 over 50. And if you think, okay, you want a family-wise control, you can click the here, preferably across the markers, it will change a different results. A little bit different from the previous one. And we come back to the p-value. Okay, all done. Fit the model again. There's the result. Then we will use this result to do the power analysis. Okay, let's come to the power analysis page. The first tab here is to choose the method. You can use the closure method, which is use the lambda and bisection or bootstrap to do the resampling. And you can type in the and you want to check in here and the significance level, assume the beta j and assume the arrow standard arrow. If the VIF can't be calculated, you also can enter the VIF manually, but in most of the case, VIF can be calculated smoothly. And you can choose the marker you want to take choice here. We have 50 markers here, so it comes from X1 to X50. Because in the multiple marker model, we seen that, okay, M1 is probably to be a significant marker, so we test the marker X1 in the power page. Okay, compute power. In here, in the main panel, we will see that, okay, the marker we test is X1 and the VIF is 1.408 and there are 15 markers. The significant level is 0.05 and assume the beta J is equal to 0.2 and then we can conclude that there are approximately 373 on sample size to be the most suitable, and then we can use a bootstrap. In the bootstrap, you change the model to multiple because we use the multiple marker model before in the model page, and to confirm your significant level, marker to test, and the minimal ungrid and the maximal ungrid. We will repeat for 1000 times to ensure that the results to be more stable. For this procedure, it will take some times. And after it finished the calculation, the figure will show in here. From the results, we can think that the, the suitable sample size for this target power, which is 0.9, might be between the 300 and 400, so it is very close to the closure calculation method, which use the lambda and bisection. And then this will refit the model many times and to resample the data and count how often the selection rule is met. So it will take some time on it. For the final part in the power analysis is the FDR curve. For the FDR curve, you choose the model, which is the multiple, and the Q value, ungrid minimal to be 100 and ungrid maximal to be 1000. The step will be 100 and repeats for 1000 times, and we run for the FDR curve. It will take some time, so I add a bar here to ensure that the user can see the procedure. In the waiting time, I can also explain that when you test the different markers, if you will see the results that the lambda method, which is the closure calculation methods, the ensample size is greater than bootstrap methods. I think the reason is that the lambda plus bisection method, which is the closure calculation method, is fast and theoretical. The bootstrap is slower but realistic. It usually gives slightly smaller power because it includes resampling noise, collinearity, and multiple testing in practice. And I have a more detailed explanation in the README page. Yeah, so you can look back to ensure that, okay, maybe the theoretical results is a little bit larger than the resampling, which is the realistic results. Okay, it takes more time to wait for the FDR curve results. So when you testing the R-Shiny-App, it will take some time. Please be patient. Okay, let's come to the graph, and we can see the model is the multiple, and the repeating times is 1000. The Q we set is 0.05. And from the blue curve, we can see that, okay, it's all below the red line, which represented for 0.05, which ensure that, okay, our FDR is acceptable. And finally, you will go to the power page, the output page, and here you can change the title name of your report. I will set the QTL design report as default here, and you can choose which section you want to include. You can click the section you don't want to include, like we use the multiple marker model, so we don't choose the SIM here, and the maximal rows for per table. Then we press the button build report here. Okay, the report is shown here. The first part is the data. Our data generated by SATSEED is 200 rows and 50 markers. And here is the histogram of Y. Then is the multiple marker results shown in the table, which include the beta hat, t-value, p-value, and LRT statistics, LOD score. And then is the p-value figures because it will take the figures you last choice in the model page. And finally is the power. The first part is the lambda NCP method, which is used by section, and we have the results here. Okay, it's about 373, and then it's the bootstrap mapping. We can see, okay, the most suitable sample size might lay between the 300 and 400, possibly to be 320 or 330. And the last part is the FDR curve. It's showing the mean selected, standard error selected, mean FDP, and the standard error of FDP. And here is the curve shown. In the last is the session info to make sure that this is the reproducible. Okay, this is all of my R Shiny apps. Thank you for listening.